next, it's time for us to train the data. Okay, so guys, I would like to create the values of x first. um, I'll create the x that like it will be range from, oh sorry, range from here minus 2.5 to 3.5. This is the values of x that I'll put x0 x1. I'll put x1 to be between minus 0.5 to 3.5 here in this range. Okay, so our x1 now, our x1 will be um, actually we have, oh sorry, actually we have x1 that we create from numpy, already created from numpy, right? So I will random pick up 10 point of x. So so and and we have the like the the output to be O here. This one will be our target. So guys, we have x1 and we have O, right? So guys, look at this. Um, we have to, oh sorry, uh, we have 50 of x. So I will random choice. This one is the random value, import random. Okay, so I will random choice that I for I in range 50 over length of x, x1. Okay, uh, this one is it is the only one we can pick up 27, right? But we need, for example, in this case, I'll use just only 10 of them. So for, oh sorry, for I in, sorry, for j in range 10. So we will get 10 index, 10 index of uh, 10 index of x, x1 and O. So I will use this one index to be this, and our training x train will be x1 index for in, oh, sorry, x1 I for I in index, and target t to be output for I in index also. So you can see that now we have x train and we have t. Okay, so guys, this one is the x train and t. You can see it also. This one you can map it together using the zip statement. So the first part here is x, and this is the Gaussian output that we will use as our target. Okay, so now we have we already have x train, that is x1 for training, and we have the target value. Next, we start our training. So I'll start from I in range. I will use like 10,000, oh, 100,000 iterations, and then we have to find immediate y. Of course, it is, oh, sorry guys, I forgot to show you our starting W. It will be np.random dot rand, and I will use one row and two columns. Let's see our starting W. This one is our starting W. Okay. Okay, so for I in range 100,000, and I will iterate through all x1. So for j in range length of x train. Okay, so our input x must be np dot array 1 and x1 is x0, right? So 1 is x0, and x train is, of course, you must get x train j. This one will be the values of x1. Okay, so this x is your vector x. So your y values can comes from w dot x. Okay, and your output will be minus y square. Okay, so this one is y square, and we will try to find our w0 and w1. Okay, so our target is tj, right? So error can be calculated by target minus output square. Okay, and now we will adjust the weight. The way that we can adjust the weight is here. The original weight is the adjusted weight can be calculated from the original one minus eta learning rate times target minus output times output, and w dot x and x. So guys, I'll start with w is w minus eta. In this term we didn't show you the eta yet, so I'll use eta is 0.01, and I'll use eta times target minus output times output, right, and times w dot x, that is y, right, and times x. Okay, so this one is x, the w that we can adjust the weight. And now we will use another terms that I would like to sum all error together. I'll sum all error together in one epoch of training x train. So I start with error to be 0, and error is error plus. If total error in this set is less than 1 e minus 5, I'll break the loop. Okay, and if I divide mod of I by 1000 equal to 0, I'll print the error to the screen and the current W. Okay, so I use current W first, and then the error, the total error, tj, not t. point, our starting point is here, this one, 0.41 and 0.916, and the final weight is this value. Okay, so let's check the output. It is, of course, it should be different from here, uh, because we must use in in our loop we use this one. We use the blue dot. Y is the blue dot x here, and this is the weight. Okay, so I'll plot the graph using this weight. Let's see. So I'll show you the result. I will use the map library, and then for I'll plot our x for I in range. So I plot our x trend. In our x trend, of course we have 10, right? Our x trend we random choice for 10 times, so we got 10 of x, and then I'll create the x temp to be np dot array. X0 must be 1 and x1 can come from x trend I. Okay, and then we'll have y temp, that is the blue dot x temp, and the predict value can be output predict is map.exp minus w.x square, right? So it must be yt square. Okay, and then I will use output predicts to be a list, and then I append output predicts dot append output predict. Okay, and then I will plot the graph PLT here between x trend and output predicts. It should be the green plus, not the line. So this one is the output that we can calculate from our weight obtained from our training algorithm. And guys, let's check the actual result, that is between x, not x trend, but it must be between x1 and output here, between x1 and the output. So it must be x1 and output. Yes, it can fit this curve smoothly, okay, using our training algorithm. So guys, I hope that you enjoy it, and if you don't understand some point, please don't worry. We have a lot of time slot that you can ask me. Thank you very much, and I hope you enjoy training the Gaussian nodes. See you guys.